A commercial drone is a small unmanned aircraft with an onboard camera that captures a bird's-eye view of the ground. It collects up-to-the-minute data, useful for many types of applications, such as planning infrastructure projects, managing farmland, and not to mention capturing those stunning movie aerials. Spanning 1.5 meters in diameter, this commercial drone is known as an octocopter because it has 8 rotors which enable it to maneuver like a helicopter. Most of the drone's components are made of carbon fiber, a strong, durable material that's also lightweight, a critical factor in aviation. A computer-guided milling machine cuts the parts before their edges are sanded smooth. This component will form half of one of the drone's legs. The mill also cuts out the upper and lower frames for the drone's body. The 2 halves of each leg are then assembled. Some of the drone's components are produced by a 3D printer that builds the parts layer by layer out of a thin stream of plastic. This component is one of the drone's 8-arm receptacles. A hole is bored, into which the arm will be inserted when the drone is set up for flight. When not in use, the arm can be detached to make storage and transport easier. The hole must be precise to ensure a secure fit. Digital calipers are used to verify its diameter before the back part of the receptacle is installed, along with the lever that clamps the inserted arm firmly in place. An electronic speed controller is attached to one end. The receptacle is then screwed to the lower frame of the drone's body. The controller's wires will connect to an electrical power harness and to the autopilot, the onboard computer that runs the drone. The 7 remaining receptacles are then installed, along with the power harness. The harness has 8 connectors, 1 for each electronic speed controller. Next, the upper frame is attached, followed by the payload mount that holds the camera and the drive which stores the data. The payload mount is linked to a servo motor, which is guided by the autopilot. The drone's body is protected by a cover. To make it, a sheet of plastic is mounted on a vacuum forming machine, and the machine's heating element is switched on. The plastic is positioned beneath it and slowly heated to a malleable state. Once the plastic is soft, a wooden mold is placed in position before the suction is activated. The sheet is now lowered onto the mold, and the vacuum draws the plastic tightly against it. The vacuum-formed plastic is set aside to cool and harden, before any excess is carefully trimmed off. A rough opening for the payload mount is then cut, through which the cover is secured to the computer-guided milling machine. This finalizes the shape to precise specifications. Once the cover is complete, it's installed on the upper frame. Four legs are now attached to the lower frame. The camera is then installed onto the payload mount. The mount pivots to angle the camera at the ground. The arms are inserted into the receptacles and clamped in position. Each arm is a carbon fiber tube with a plastic rotor that's driven by a small motor underneath. When an arm is inserted, its motor makes contact with the electronic speed controller. An autopilot is also installed. It will execute a programmed flight path and operate the camera. It also operates the servo motor that moves the payload and the electronic speed controllers. The drone operator can communicate wirelessly with the autopilot using remote control.